Hello, standard geometry students, and welcome back to some more online geometry. Today we're going to be looking at section 12.3. But first, have you noticed what's right in front of me? I just took out all of these nice, wonderful hot cookies right from the oven. I can't wait to eat them, but I had to show you because they're all what? Circles. And my favorite thing to do when I get cookies right out of the oven is just to cut off, because they're too hot to eat at this point. I mean, I'll eat the rest of it, but cut this off. Ooh. And eat just a little bit of that hot cookie. What did I just eat? Besides a cookie. And geometry, what's that called? Well, that's our next section. We're going to be looking at cookies. And I'm really sorry that you're not in class, because this is typically the day that I hand out cookies to everyone. But before we get into our new lesson on cookies, you remember geometry's all over. Let's review what we learned last week. What happens if I have a point on the circle and another point on the circle? So any 2 points on the circle. If I connect those 2 points, what's that segment called? Anybody remember? That segment is called a chord. What chord do we already know a lot about? The one that goes right through the diameter. That's still called a chord. It's called the longest chord in the circle. It's called the diameter. And of course, that diameter is going to be made from a radius and another radius. So you can see any other chord that I were to draw in, if I connected these two, you're going to end up with it being not longer than the diameter. So the diameter is the longest chord. What happens if I made that into a line and I put arrows in it? So it goes on and on and on forever. So it still contains the chord. What's that called? That is a secant. So a little review of that. We're going to be talking about these the rest of this chapter, so I want to make sure that they all come in loud and clear. So chord is the segment, a secant is a line that contains the chord. And then remember the one I can't draw on, the one that just kind of touches the side up here or any part of the circle over here, that was called a tangent. And the point where it touched is called the point of tangency. And any radius that I draw into that point of tangency makes a right angle, okay? So that was a real quick overview from what we had last week. Now, we did have one angle last week, and that was an angle that had 2 radii, and its vertex was at the center. What was that called? So that angle, whose radii, and vertex is at the center. That is a central angle. And we're going to be coming back to that. So I just want to keep reviewing that. So you know what a central angle is, you know what a radius is, you know what a diameter is. A secant is a line, a chord is a segment, and then a tangent, the one we can't draw on the circle at all. So what we're going to be looking at is exactly what I started saying with my cookies here. Man, they are too hot for me to even touch. I'll have to take those away. We're going to be taking a look at what's that called if I just ate that one piece of the cookie, okay? So what is that called right here? So what's this part called, and what's the part of the cookie that I ate? And again, if we were in class, you'd be all getting one of these cookies so that you could look at it. Well, first of all, let's take a look at a cooled off cookie. For Easter, I did make some sugar cookies, so I kept one and made it into very large so you can see it. I wanted to do it with a pizza, but I didn't really have any pizzas, so we just went with this, okay? So now, what kind of angle did we just review? Would this be called if this is the center of this circle cookie? Okay, the one that came out with 2 radii, that's a central angle. This piece of cookie, or this piece, is called a sector of the cookie, or a sector of the circle. So you can really think of a sector as just a piece of pie. Okay, it could be the smaller piece, that's a sector. It could be exactly half. That's the sector. Or it could be the bigger piece, like the Pac-Man piece. So Pac-Man is actually a sector in geometry. So our sector is just any region that's part of the circle that is bounded by an arc and 2 radii. So any of these would be sectors. So I actually have a smaller sector and a larger sector here, okay? Another vocab word that we're going to be looking at then, so we're going to be studying sectors of a circle. We're going to be talking about the arc length, okay? Now, you have to remember that arc length is not the same as the arc measure. So if I measured the whole circle, I'd be measuring in degrees. So the whole circle is obviously 360 degrees. Not a problem. I know that's 360 degrees. But what happens if I just wanted a little piece of the arc length? Would that be part of 360? No. That would not be part of 360 because think, if you had 2 different size circles, they're both 360 degrees. Would an arc in this circle be the same as an arc in this circle? Obviously not, because their radii are very different, okay? So you have to remember when I'm looking at arc length, it depends on the length of the radius as well as the measure of the arc. So we're going to be looking at arc length today. We're going to be looking at sector area today. And then we're going to look at one other thing, and then I'll start looking at some details. Remember as we first had those hot cookies out that I cut just a piece of the cookie out. Okay, that piece, it's like I cut this one out, that piece is called a segment of the cookie. So we're also going to be studying the segment of the cookie. Now, if you take a look at this, you can kind of look at where we're going to go from here. So I know this whole thing together is a segment, a sector of the circle, or of the cookie, and this would be a segment of that circle. So basically, what 2 things would have to be put together to find the sector? Well, obviously the segment, okay? Even though a segment sounds like it's just one segment, it's actually this whole area of this. So one chord bounded by an arc would be a segment, okay? And what shape would this one be? Yeah, we studied those a long time ago. Exactly, that is a triangle. So keep that in mind as we start looking at what we're doing here for today. So let's go ahead and start in our notes now, knowing that we're really just as easy as eating cookies. So we have 12.3 today, and 12.3 is on sector area and arc length. So as I said, the sector is just like a piece of pizza. So just think of it as a piece of pizza. It's part of the area of the circle. So you have to remember that area is pi r squared. The area of every circle is pi r squared. Because I'm working with sector area, the units for that area are still going to be in square units. So if I was working in inches, it'd be in square inches. If I was working in millimeters, it'd be in square millimeters. Whereas when I'm working with arc length, that's going to be that part on the outside. That's going to be part of the circumference of the circle. So I wanted to review that before we get started. Circumference is going to be 2 pi r, or pi times diameter. So make sure that you're ready to look at the difference there. The arc length will be part of the circumference, where the sector area will be part of the area of the circle. Now, if we know it's part of the circumference, then the units there are not going to be in square units. It's just going to be in what we call linear units. So it's just like feet or millimeters or inches, okay, whatever I have, but not to the second degree, okay? So remember that we have arc measure that we talked about last week, where we were looking at the measures. Those are in degrees, where the arc length is talking about actual how long is it on the outside. So it's like saying I want to put a ribbon around the whole outside, okay? So that's our kind of basic vocabulary. Now, what we're going to be looking at today then is we're going to be looking at how can we find the areas and the lengths of these different pieces that we were just talking about. So let's talk about, first of all, our sector area. Now, think about this, because it's really not too hard. You're thinking of a piece of pie, or if you want to say, think of a piece of pizza. So you all eat a sector, unless it's cut in squares, but most of our pizzas are cut into sectors. So you're really looking at sector as just a piece of pizza, okay? Now, some of you may say, well, I'm going to eat half the pizza, okay? Well, then that's still a sector because I still have a radius and an arc. So when I look at my symbol for a sector, I could call that sector PQR. So I'd write that as sector PQR. So that means that it starts on the circle at P. The center of my circle is Q, so that would be called circle Q. And then my other point on my circle is R. Now, if I move that, I could call this then sector SQR, and that would be this part of the sector. So when I say sector SQR, I always look for the smallest part of the sector unless it tells me to do the shaded area. So PQR would always be the smaller part, okay? And then this sector would be named sector TQR. So now notice that I put in the whole circle as a radius of 10. So if I just wanted the whole area of the circle, how would I find the area of the circle? Pi r squared. So if I wanted to do the area of the circle, I would have pi r squared. And I would just say 10 squared times pi. So the area of this whole circle is 100 pi. But what happens if I only ate half the pizza? Did I eat the whole area? So if I'm just eating this top half, what would I have to do? See, it's not that bad, guys. All I'm looking at is what part am I eating? So if this was 100 pi, this would simply have 100 pi divided by 2. So the area of this sector would be 50 pi. So I'm really always comparing it. That's a 50 pi. That would always be compared to the area of the whole circle. It's going to be less than the area of the whole circle, so not too bad. Whatever the units are here, it would be in square units. So if it was in inches, that would be in square inches. So have any ideas how you would find the sector area here? Is the sector area going to be 100 pi? Well, remember the sector is bound by 2 radii and an arc. So there's my sector. Again, it's like you ate a fourth of the pizza. There you go, a fourth of the pizza. That's really all you're doing is saying a fourth of 100 pi. So 100 pi divided by 4, or 25 pi. Again, if those units were in inches, that would still be in square inches. Now, are you catching on to how I can do this pretty easily if I have just half a circle or a fourth of a circle? But what if my area is something that's not quite as easily looked at? What happens if my area is, in this last one, 70 degrees? Well, all I'm going to do is the same thing. I'm going to take part of that circle. So let's think about it like this. You know the whole circle. So my whole circle was 100 pi. And then I'm just going to multiply it by the part. It was easy if I said it was exactly half for my sector. Probably should use a different color. But if it's not, I can still do it the exact same way. I can say my whole circle is 100 pi. And now what part do I have? Well, I have 70 degrees out of 360 degrees. And that's literally all I have to do. So I can say 100 pi times 70 ABC 360, and I would get my answer. That's really all you're doing. Now think back to what we said before. Could I do that same thing for each one of these pictures that we started with? Certainly. I could think of that as 180 degrees, and 180 out of 360, exactly 1/2. Or I could think of this as 90 degrees, and 90 out of 360, exactly 1/4. So I'm really doing it exactly the same way. I'm just saying take the part and multiply it by the area of pi r squared. So sector area. Now, remember that's really not our whole goal, because our goal is to say, by hot cookie, I cut off just this piece. So I want to know what is the area of this piece. Okay? So now let's move into the segment. So the segment is like cutting off that hot piece of cookie. Okay, and so our second concept is saying I want to look at segment area. So segment area, you're thinking of cutting off the edge of the sector. So I could say a segment here, here's my whole sector, and then I just cut off, and there's my segment. Okay, or here I can just cut off, and that's my segment. Here I just cut off, and that's my segment. So when I say a segment of the circle, I'm not thinking of a chord. I'm thinking of a chord and its arc. A chord and its arc. A chord and its arc. So my segment area then, you can kind of see what we had in our cookie. It's going to be the whole sector area minus the triangle. So all I would have to do is say, okay, I'm going to do the sector area, which we just said. I went ahead and put the 10 back up in here. So if I were looking at the sector area for this, I would just say, okay, the sector area we just did was 100 pi. So remember, that was our whole area times, we had a fourth or 90 degrees out of 360 degrees. So that's the one we just did. That was a fourth of the circle. So my sector area was 25 pi. But is that going to be the area now of just this piece? Obviously not. But all I have to do is take off the triangle. So how do you find the area of a triangle? I told you, chapter 12 is really a lot of review. I'm going to take 1/2 base times height. So I'm just going to do the exact same thing we did before. The area of the circle times the part, excuse me. So in this case, 1/4, so 25 pi minus 1/2 base times height. Well, in this circle, my base and my height make a right angle. So here, I would just say minus 1/2 of 10 times 10. Okay? And then I can just put that in my calculator, or I could leave it exact. 25 pi minus 1/2 of 10 is 5, times 10 is 50. So my answer would be 25 pi minus 50. And that's the answer. Now, when we get to the reteaches, I will show you how you're going to do it if you don't have a 90-degree angle. So right now, I just want you to realize the only time you can use the radius here and the radius here, because remember they're both radii, is if I have a right angle in between. Now, the radius would still be congruent, but it's not going to be the base and the height, because the base and the height, remember, have to make a right angle. Okay? So segment, just like cutting off that piece of hot cookie. Okay, and now our last thing here we're going to be looking at is our arc length. Our arc length. Okay, and our arc length that we already talked about is just going to be the part of the circumference instead of part of the whole area of the circle. So if I want to find the length of arc DC, okay, so if I want to find the length of arc ABC, I would just say, well, the circumference is just pi times diameter. So if the radius is 10, the diameter would be what? So I'd have 20 and my circumference 20 pi. And they know what the length of this arc would be if that's 20 pi. See, it's kind of common sense. It would just be 10 pi. Now remember, if that's in inches, it's not in square inches anymore. It's just going to be in regular inches. Okay, now, how would I find the arc length of DC? So let's turn to our red pen here. And in our red pen, DC, I say, well, again, my whole radius is 10. My diameter is 20. So my circumference is 20 pi. Oh, I got pink instead of red. That's okay. And then times my part. What part do I have? 90 out of 180, or 1/4. So my answer, the length of arc DC, would be 5 pi. Remember, that would be in inches or whatever. Okay? And then let's do one more here, and then we'll get into some guided practice. What happens if it's not easy to find? You do this the same thing as what we had from before. So you're still going to say my whole circumference was 20 pi and then I'm going to multiply that by what part? So in this case, 60 degrees out of 360 degrees, or 1/6. So my answer would be 26 pi, which simplifies to 10/3. Now we'll go through some more examples as we get to the reteaches here, but I do want you to put in your notes the formulas. And so I put the formulas on the sheet here, okay, and that's basically what we were just looking at, okay? The formulas are the big thing in 12.3. So in 12.3, you're looking at the sector area, okay, which is just a piece of pizza, is the circle's area times the arc degree part. So they call that m degrees out of 360. And the area of a segment is always just the sector minus the triangle. Okay, and arc length is going to be circumference times that same part. Okay, so a lot more calculations today. Let's take a look at the reteach video and see if we can get some more examples there. Okay, I know that's a little bit more work, so make sure you show your work on your homework. Okay, and I just got reminded, I forgot about the joke from last week. The last week's joke was, what do you call the force on the surface of a balloon? What do you call the force on the surface of the balloon? Sphere pressure. The force on the surface. Oh, okay, laugh about it later. Don't forget you get your formulas, and I'll see you for the reteaches.